1231. But if we're servicing the just the gas part in it, putting in a pre-charge, then they cover that in another part of the manual system just to make things interesting. Airbus does this as well, that they'll put the gas servicing for the landing gear, the nitrogen pre-charge that you put on it, they put that in a different part of the manual than the oil. So with landing gear on an aircraft maintenance manual, in the practices and procedures part of the Boeing aircraft maintenance manual. Boeing maintenance manual, there's a part 1 that is called systems description section. Then there's Boeing maintenance manual part 2, which is maintenance practices and procedures. This is maintenance practices and procedures. This document is presented in a portrait format. The system description section goes flat this way. That is called landscape format. So we're in practices and procedures. This is how to actually maintain the airplane. So in our paragraph number 2, they're listing our landing gear shock strut fluids. What are we allowed to put into our landing gear? And I picked this because they've made a bit of a conflict between the text that follows and this particular section here in terms of how they've worded things. This reference number D00070, this material, if you look it up, it will also tell you that it is BMS 3-32, Boeing Material Specification 3-32, Type 1 and Type 2. This is a premixed fluid. Actually, this would be a different specification number. Yeah, sorry about that. That'd be a different specification number. This is hydraulic fluid without any Lubrizol added to it. So we have MIL PRF 5606, also known as MIL H5606, the same basic chemical. This is what you would use in your landing gear shock strut. You do not use this landing gear in hydraulic systems on airplanes, however, because it is a petroleum-based hydraulic fluid. It burns at a very, very low temperature. Its flash point is not very high. So if we use this in an aircraft brake system, we can have our brake have a fire. The fire would spread to the aircraft and destroy the airplane. There's carbon brakes on a lot of 737 next gens. The newer aircraft are getting more carbon brakes than the steel brakes because they're lighter. The carbon brakes can catch fire without any chemical contamination. So with a carbon brake equipped aircraft, if we had MIL H5606, petroleum-based hydraulic fluid, we could very certainly have a fire if there's any kind of a leak. So we don't use this hydraulic fluid for the brakes, but we do use it to service the landing gear strut. If we used Skydrol in the landing gear strut, some people have used Skydrol in their landing gear struts, but Skydrol tends to eat seals very rapidly, so that you end up having to take the gear out and repack the gear, change all the seals in the gear more frequently if you use Skydrol than petroleum-based hydraulic fluid. So we have another petroleum-based hydraulic fluid here as well that they're specifying. This is probably, like I say, for preservation and operation. I don't know. I've never worked with this hydraulic fluid. Maybe the gear might be shipped with it from overhaul of that particular fluid. Or maybe NATO just prefers to use that as their hydraulic fluid. At Continental, all we would have is 5606. And quite often, then we had just stock 5606, and then we would have to add this lubricant called Lubrizol, 1395. So we would have to mix this in, about 1.5% lubricant by volume. So right here, you could also get a pre-mixed shock strut fluid, where it's 1.5% Lubrizol. The pre-mixed fluid, BMS Boeing material specification 3-32, type 1 and type 2. I really think that this should be listed up here with a separate specification number in terms of what your approved consumable materials are. I think if we look it up, we will find that BMS 3-32 has a different reference number, so it should also have been listed up here at the top. So the premix fluid is the recommended fluid, because then you don't have any chance to have an error in your mixing. And the ratio of the oil to the actual hydraulic fluid is important. And one of the reasons is listed a little bit further down, right here. So if your BMS 3-32, the pre-mixed fluid is not available, and we have to fill an empty shock strut, it is recommended that you pre-mix your 5606 hydraulic fluid with the lubricants before you add it to the strut. So you mix it in your servicing cart before you put it in the strut. And it says if this is not possible, you can pre-mix 1 part lubricant with 10 parts minimum of fluid before you add the lubricant to the strut. You don't want to fill the strut with your 5606 and then go to the top with your lubricant and pour it into the gear to add it to the gear. And the reason for this is probably stated on the next page. But what will happen is if the lubricant doesn't mix properly, which it won't if you just pour it in after the fact, it'll settle at the bottom of the gear. You won't have proper lubricating characteristics. Your seals will wear out more quickly, and then you can also damage the metal of the landing gear by having undiluted lubricant sitting in one spot. And that caution is, as I said, it was on the next page. Do not add undiluted Lubrizol directly to the shock strut. If you put undiluted Lubrizol into a strut, it will collect at the bottom and not mix correctly with the fluid. The undiluted Lubrizol can cause the strut seals to expand and become soft, and they'll reduce the service life of the seals. So you'll have your landing gear will start leaking. And then if you go to the back of the landing gear, when you're doing your inspection, walk around, you'll see black streaks coming down out of the gear. Your seals are melting. And then if you have to change the seals on the main landing gear, you have to jack the airplane up, raise the gear halfway and stop, and then put some blocks underneath it. And then you slide your chrome piston out, and you have to change the shock strut seals. And that's quite a bit of work. You don't want to do that if you don't have to. When it is necessary to top off the shock strut fluid, do not add small quantities of hydraulic fluid without Lubrizol over many courses of servicing. If you do this, it'll decrease the lubricity of the fluid, and the strut causes damage, and then you can have damage done to the strut. You want to add Lubrizol directly to the shock strut. It must be pre-mixed with some hydraulic fluid. Minimum of 10 parts of hydraulic fluid to 1 part of Lubrizol. You can avoid all of this if you just order pre-mixed hydraulic fluid with the lubricant already included. That'll be more expensive, but it will avoid a lot of difficulties. If you don't order it ahead of time, then you want to make sure you have your 1.5% by volume. And they're also adding a 1% by volume of this methyl oleate. This particular fluid, they're saying they have 2.4% by volume Lubrizol, this NATO fluid. And here actually they're saying mil 5606 fluid plus 2.4% by volume Lubrizol. So that's the servicing of the shock strut fluid for the landing gear. Then if you service the shock spread fluid, then you would have to add a nitrogen pre-charge to the gear as well. You'd have to put nitrogen in the gear, but that's covered under another topic in chapter 12. Now we have the fault isolation manual for the Boeing 737. When you're working on a Boeing 737 and the airplane breaks, something's broken, you have a fault, pilots think that there's a problem with the airplane, then you have, you go first to the fault isolation manual. That's the first manual that you go to, is the fault isolation manual. Why this thing's using the monitoring computer, I don't know, but anyway. We go to our fault isolation manual, and how do you find a fault with the airplane? So you can have observed faults or cabin faults. Boeing separates it into those two categories. So we'll go with the concept of a observed fault. You do BITE. BITE means built-in test equipment. BITE, built-in test equipment. So when you do BITE, you can get fault codes if a component is equipped with the ability to give you a fault code. They'll give you a maintenance message. Maintenance message will be a code of some sort. You will see more details in Figure 2, which is on the next page. Once you have a fault code of some sort to work with, then you go to the fault isolation task in the FIM. Is your fault code or a description of the fault? Find your task in the FIM. So there's a numerical list of fault codes in each chapter, each ATA chapter. So ATA 28 will be fault codes in the fuel system on the aircraft. ATA 73 would be engine fuel. ATA 28 is aircraft fuel system. Then you follow the steps in the fault isolation task. And if you get to the point where the task says you corrected the fault, the fault is gone. The goal is to follow the troubleshooting procedure until it says you corrected the fault. This is 32 - how to use the FIM. This is in the front part of the fault isolation manual. So it isn't 32-00-00. It's 32 - how to use the FIM. We have 32 - effective pages. This shows the revision date of each page. 32 - how to use the FIM. XYZ, that means we're working on what airline? Is XYZ? The answer is absolutely no airline in the world. This is just a training number I made up. Usually this might say CAT, CAL, UAL, whatever your airline code is. See if I can find what Thai Airways is in Boeing's manual logic. TII, Tango India India, would be Thai International Airways. So if this fault isolation manual was Thai Airways, this would say Delta 633 Alpha 103 - Tango India India, TII. Effectivity, here it says XYZ all. That means this information is effective to every airplane that's in this imaginary airline of XYZ. So fault isolation task index. Some airplanes have built-in test equipment. If the system finds a fault when you do a byte test, it will give you a maintenance message. Maintenance message can be any of these. It can be a code, numerical code. It can be a text message. You can get just a light. You can get some kind of an indication, physical indication on a gauge, for example. So your built-in test equipment can give you some information to tell you if the system is working or if there's a fault somewhere. To find the fault isolation task for a maintenance message, you go to the maintenance message index in the chapter for the applicable system. If you do not know which chapter is the correct one, you could look at the list at the front of any maintenance message index. For each system or component, LRU. LRU means line replaceable unit. Something you can go out on the flight line, remove, and install. You don't need to be in a hangar. You don't need to be in an overhaul facility to change it. You don't need a lot of heavy equipment. Line replaceable unit would be something like an electronic box in the electronics bay that you can remove rather quickly. Indicator in the cockpit. So for each component or system that has LRU with a byte capability, the list gives the chapter number where you can find the information. What they're saying here is we're working in ATA 32 chapter, but there might be some things that we're not sure if it will be in 32 or if we're even in the right part of the book. So we can look at this maintenance message index, and perhaps it'll help us then to find quickly that we're in the wrong ATA chapter and we need to look somewhere else. Then you find a maintenance message for the applicable LRU or system in your index. Then you find the task number. Then you go to the task in the FIM, and we'll show you how to do that. This maintenance index that I'm talking about would be this one, maintenance message index. So maintenance message index here too, we're in ATA 32. We're not in the front of the book. This is in ATA 32. Airline, we verify, yes, we're still working on XYZ. Yes, XYZ, every airplane in there. So it says the ground proximity computer. We might think that the ground proximity computer would be in ATA 32. ATA 32, the landing gear, once it's compressed, we know that we're on the ground. But the ground proximity computer that's here has nothing to do with ATA 32. They put it in ATA 34. Anybody know what ATA 34 is? That'll probably be a test question. So our anti-skid control unit, that's still ATA 32. Okay, that's good. Auto throttle system. Well, the engines are ATA 70, 71, 72, 73. Engine controls are ATA 77. Throttle, that controls engine fuel, that's ATA 73. But in this case, I can look and it says, auto throttle system is in ATA 22, which is auto flight. So the auto throttle system, even though you're controlling the engines for the auto throttle system, it is distinctly a part of your auto flight system, so you would look in ATA 22. Auto throttle system is one of those systems that if you're new, just started at the airlines, you understand how to use the manuals, you've got your little sheet, you say what ATA you're looking for, you might say, oh, okay, maybe that's under engine controls, and look in ATA 77. But then if you look at this index here, it'll say that even though the auto throttle system is controlling your engine, it is actually part of auto flight. So this is your maintenance message index. And since Boeing will deliver this document, this ATA 32, as a standalone PDF document, it comes straight from the DVD disc this way. they realize that perhaps on your computer you've only been given this one document to look at, to work for. So even though this is covering a lot of information that's not part of ATA 32, they just put it in here to give you help in case you need to go and redirect your attention to some other part of your ATA system. So if we have a fault code, then we would do this task. This here we would follow this. So basically, if we have things in the left, we will then do the things in the right. So it's divided along this line here. If you have maintenance message from byte, follow these steps. Observe fault description, follow these steps. A fault code, then you go to these instructions to tell you how to use the manual. This list of instructions is in the front of every ATA chapter in the FIM. In the aircraft maintenance manual, they don't tell you how to use the aircraft maintenance manual in each chapter. They only do that in the front matter of the book in ATA 00. Some companies I've worked for, when you go online, they don't give you anything before ATA 11 in the maintenance manual that you can access, which is a mistake because you need to have access to everything. So you want to be able to access ATA 00 if you're in the AMM, Aircraft Maintenance Manual, and you can't remember how to use it. That will tell you how to use the AMM. In your FIM, every chapter will have this section with these particular pages explaining how to use the FIM. The first two digits in a fault code are the FIM chapter that you need. So if you have a fault code that says 32 at the front of your fault code, then you know you're in ATA 32. Then you go to the fault code index in that chapter to find the fault code. Fault code index would be here. One example of in the fault code index of a fault code is this: 32411000. That would make me think it's going to be an ATA 324110. They've got it in FIM task 32-42, task 814. If we click this in a real computer, in a real airline, it would automatically take us to task 814. However, since I did not install the index file for the fault isolation manual on this computer, then all of these links are disabled. So I didn't install the index file. So we want to go to the 32-42 task 814. So we go Control F at the same time. And we type in 32-42 81. Didn't type 814 because there's this unusual thing with this particular page. It makes it a little harder to find it with the shortcut of searching by keyword. Usually they'll only have it down here. It says 32-42-813. But for whatever reason, Boeing usually will not just have one piece of a sentence carried over from the previous page and bring it down here, and it's all by itself on this next page. Usually they won't split a paragraph. So you have to watch out for end of task. So if we were up here on the previous page, task 813, and we go down, we're reading this paragraph here. You'll notice it does not say end of task. So you want to go to the next page until you find it where it says end of task. Yes. Always read all the way through to end of task, even though you may have gotten down to this part of the FIM and said, oh, that solves my problem, I don't need to read the rest. Always read all the way to the end of every task, because maybe there's something down here that that might contradict what's happening up here, or you'll find that the description down here is more correct than the one that's up there for what you're working on. So on this particular task, on the bottom of the page, 32, 42 tasks, 813, 814. So they've got two tasks together on this one page. So the one we were looking for was brake pressure indication 0 or low. This one right here. Now, as a reference, Boeing mentions this right here. Description, they say refer to SDS 32-41-00. This is the system description section. This is what we would call a Gen FAM part of the manual. Be careful because SDS parts of the Boeing manual, even though it says aircraft maintenance manual on the page, it is not a valid maintenance reference for signing off your logbook or for working on the aircraft. It's only a system description. It's only for educational purposes only. And quite often the information in the SDS might be out of date, might be incorrect, because the people that write that are teachers like me. They're not engineers working on the actual aircraft. So sometimes your SDS can be several years out of date and not reflect things that are in the real world on your airplane. So if you have 0, indicating 0 on your brake pressure, anybody know what an accumulator is? Accumulator, hydraulic accumulator. You could say that this is an accumulator. You have a steel case, and you'll have a diaphragm in between. You put nitrogen on the top. There's hydraulic fluid in the bottom. That's part of your hydraulic system. The fluid comes in, goes out. So you have your fluid in the bottom part of this, and at the top, you've just got a lot of nitrogen pressure on the top. If you go up in the cockpit and you press the brake pedals about 10 times, or you take the ailerons and you cycle them back and forth, you bleed residual pressure off of this lower portion of the hydraulic accumulator. Up at the top of the accumulator, there's an indicator that will read how much nitrogen pressure you have in the accumulator. If you're in the cockpit as well, you know, your brake pressure might bleed down to where you don't have any brake pressure. But if you have 0 brake pressure and you think you should have it, when you go down to the accumulator and you look at the pressure gauge on the accumulator, it should be 800 psi, 1200 psi. It should not read 0. There have been problems with this because Boeing in this FIM task, this fault isolation task, they'll assume that you have a nitrogen leak outside of the accumulator. They forget that inside the accumulator, your diaphragm can rip, tear, which means then you have an internal leak within the module itself. So if you go to the accumulator now and you hook up a nitrogen bottle and you start blowing nitrogen in here and your diaphragm's ripped, you're going to blow nitrogen gas into your hydraulic system, into the fluid, and you should not have nitrogen gas entering the fluid. If you blow a large portion of a cylinder because you're over at the bottles, if you blow that cylinder into the hydraulic system, then you cause all kinds of trouble and damage, and you'll have a big delay. American Airlines asks this question when they interview new mechanics that are coming to interview. And then you've got this FIM that tells you, oh, just hook up a nitrogen bottle and put pressure on the top of the accumulator. But it never mentions that you should consider the fact that the accumulator internally, that this diaphragm seal may have ruptured. So they're saying possible causes, you might have a nitrogen gas leak at the tube connector. Brake accumulator transducer might be bad. Last thing here they say, the brake accumulator might be bad. And the only thing in the accumulator that can fail is that diaphragm seal. So if you go and you do this leak check, by adding more nitrogen, do this task, hydraulic brake accumulator servicing, this one right here. You go and you hook it up and you put nitrogen in. If you have a torn accumulator, you do a lot of damage to the airplane. Probably get suspended or in trouble, but the manual told you to do this. But you have to think carefully, because sometimes the people that write these manuals are not aircraft mechanics, and they haven't consulted anybody who's an aircraft mechanic. They're technical writers. All they get paid to do is to write manuals, and they never have actually worked on anything bigger than their laptop. This related data, they reference SSM. And I will show you SSM, Simplified Schematic Manual. SSM, in conjunction with your FIM, your Fault Isolation Manual, and your SSM, these are your two primary manuals you should go to first for your troubleshooting. The FIM and the SSM. Go to them first. Then from there, you can start looking at your wiring diagram manual, your aircraft maintenance manual, your illustrated parts catalog, other things as well. But your simplified schematic manual is a great tool, and you'll find a lot of A&P mechanics out in the real world. They don't even know this exists, this SSM. They ignore it, even though the manual clearly tells them to look at SSM. A lot of them never use it. And the SSM, as I will show you, is a fantastic tool to help you with your troubleshooting, because your fault isolation manual, this is ATA 32 down here, just ATA 32. Your SSM, however, will take into account that ATA 32, you may have other things that feed in and influence the system that you're working on, and it will show things that are not in ATA 32 in one sheet, so you can get an idea of how everything's working together. So this particular task, if you followed it exactly, did exactly what they tell you to do in the FIM, without thinking, you just go here to the number one cause, leak. Nitrogen gas leaks. They think that maybe there's a nitrogen gas leak at these locations. So you follow the steps, step by step. You do exactly what the manufacturer has told you to do without thinking any further. They think that you could have a gas pressure tube connection at the brake accumulator leaking, gas pressure tube connections in a manifold assembly leaking. This can happen. Gas pressure tube connections to the brake accumulator pressure gauge, brake accumulator charging valve. Honestly, these items almost never get touched. They're not really susceptible to getting hit by anything, any vibration. It's a great theory, but this stuff doesn't break. The connections, if they were properly installed at the factory, the guy used a torque wrench, click. It's signed off as being, being done by a QC inspector as they're putting the plane together. It gets installed, and then it's not something that's going to leak unless they've changed the accumulator at some point. Accumulators don't fail very often. If you still have the original accumulator, brand new, might be a little dirty, but you can tell, it looks like it's never been changed. Probably the accumulator has failed internally. The other more sensible thing to look at first is, maybe you're not getting a correct pressure transmission to your cockpit gauge. Something else might be intermittent there. That's another thing you'd look at. But nitrogen gas leakage, they're assuming you've lost the nitrogen gas from the top of your accumulator because it's leaked outside of the accumulator. But if it leaks inside the accumulator during flight and as the airplane's taxiing and everything else, then you're just basically putting all of your nitrogen gas into the aircraft. So if you have a ruptured diaphragm, they don't take this into account because the person writing this is not actually working on real aircraft. So anyway, if you find a nitrogen gas leak, you would repair your leak. You would then service with your nitrogen gas. And then here's the step, a little bit of a terminology that they'll use. If the brake pressure indication does not show low or zero on subsequent flights, then you corrected the fault. but I have to sign the logbook off saying I fixed the fault before the airplane flies. But then the airplane has to go fly for me to know if I corrected the fault. Not really possible. You can't go fly the airplane until the logbook has been signed and you said, yes, I fixed it. So basically what you do in this case is you sign off performed tasks as specified in this FIM task 814 32-09-814. You say you found a leak or whatever you've done, and you just make a note to say pilots requested to monitor the brake pressure indication on subsequent flights, and if there's a problem, just write it up again, take the aircraft out of service. Now, they've gone to all this trouble with the nitrogen, but honestly, the most likely cause of your problem is not going to be number one. Most likely number two, your brake accumulator pressure transducer will be the problem more often than any of the other choices. So look at your brake pressure transducer, make sure that that's not the problem. You troubleshoot that. So what they've got then is choice number 3 is replace the brake accumulator. The way they organize the FIM is when they write it is your fault isolation. You have choice number 1, number 2, and number 3. You would think they would really put this in the order of what most commonly would fail. So logically, you would think, oh, choice number 1, that's the most common thing, that's why I'm looking at it first. But actually, no, you're going to choice number 1 because that is the cheapest one. This procedure right here, this doesn't cost much money. You don't have to buy any parts. You don't have to order anything. You've got nitrogen, put nitrogen in the airplane. They're starting the troubleshooting with the cheapest option, not the most likely option. Option number 2, changing this pressure transducer. That might not be cheaper than an accumulator, but this is pretty quick to do. You don't have to break into quite so much stuff. And then replacing the brake accumulator is their last consideration. But if you're replacing the brake accumulator, you probably had trouble when you did this nitrogen gas servicing up here because you will have blown nitrogen bubbles into your system. Any of you ever go to a hospital to give you a shot? If they've got a syringe, the doctor will take the syringe and he'll point it up and he'll squeeze it. Like if you're going to get your teeth extracted, they give you an injection. If they take the bottle, they put the needle in and they fill the syringe, then your anesthesiologist or your doctor, your dentist, they'll take the needle and they'll point it upwards. They'll let the air go to the top of the needle, and when they push, they squeeze any air out of the syringe and needle, get a little bit of fluid come out. Because if you take air and inject it into your bloodstream, you can have, forget the medical terminology, but basically you could die if you inject air into your bloodstream. It can cause death. Airplane's about the same. It doesn't want to have nitrogen bubbles or large amounts of nitrogen blown into the hydraulic system. It's designed not to have air in it. So I just brought this particular fault isolation task to your attention because understand that the fault isolation manual is great, but quite often the way that Boeing writes it doesn't follow a logical sense in terms of what normally fails. They go with the cheapest thing first, then follow on. Other parts of the fault isolation manual, they don't do that. They'll go with the most expensive thing first sometimes because they think that that's the most likely thing to fail. So with avionics things, a lot of times they'll say they think that this great big module from the electronics compartment, this module that's probably $70,000 or $80,000, change this first because it's quick. You take the screws out, you pull that, put another one in, and usually the fault doesn't come back. But a lot of times, electrical systems, it's a relay, a cheap relay that's your problem first. So it depends on who writes it. but keep in mind that it's not absolute with the fin, but you have to do step 1 first, then you have to do step 2, then you have to do step 3. With the fault isolation manual, sometimes you have to use a bit more sense. So, fault isolation manual. If you work on Airbus A320 usually it prints out a little 7-Eleven receipt, and it gives you a fault code for almost everything on the airplane. It'll give you a fault code. You go to Troubleshooting Manual, TSM. That's their version of fault isolation manual. And you follow the steps. Airbus A320 is a very pleasant airplane to work on because the airplane helps you along. It says, I'm broken, and this is what you have to do to fix me. Boeing, a lot of the time you have to dig more. You have to do more investigation to figure out. You think something's wrong, you know something's wrong, but you have to dig more to get the information. So an important thing to remember is assumed conditions at the start of your troubleshooting test. They're assuming your external electrical power is on, your hydraulic power and pneumatic power are off, the engines are shut down, and they're assuming no equipment in the system is deactivated. Don't forget this. If you have anything that's deactivated, you have to consider that maybe you might have something in one ATA system that might be deactivated, but there's some electrical signal that would have come off of that and gone to your other component that's not in the same ATA system, might have caused your fault to show up. They say here, the list of possible causes has the most likely cause first and the least likely cause last. But in this case of the brake pressure problem, I would disagree. I would say the most likely cause would be the transmitter, then some kind of external nitrogen leak, and then after that, actually no, I'd say the external nitrogen leak would be the least likely. Internal leak in the accumulator would be more likely than. You can use the maintenance records of your airline to determine if the fault occurred before. And quite often, if you can go back several years, you might find a certain fault that keeps coming up time and time again, and somebody removes and replaces a box in the electronics bay because it's quick, and the fault goes away. But the memory, the brain for that system, for that fault, it's in the box. So most of the time, if you change the box, you put a new box in, of course, you go in the cockpit, you won't see any fault because you removed all memory of the fault, but you didn't correct it. Case in point, 737 I worked on has a yaw damper. The rudder is controlled so that you don't end up with oscillations in the aircraft. That's something called yaw damper. And there's a yaw damper computer in the electronics bay, and that had been changed 5 times in about 2.5 years because pilots would say that they got a warning that the yaw damper wasn't working right. And one of the times the guy wrote that he had fault code 1604, I think it was. If you looked at the fault isolation manual, it said if you have fault code 1604, the switch in the overhead panel is defective. He signed off that he just went down and removed the box and changed the box, fault went away. So he did. 5 people had changed the box when it was always just the switch in the overhead panel. It was slightly loose. When I touched, I could feel it was a little bit loose. I changed the switch. Very cheap, but not the thing that they had and the most likely to fail first, and also the fault message in the box. The person ignored the fact that it had the fault message. The other people that had changed the box, I guarantee when they did the bite, the built-in test, that they would have probably seen the same message as well, telling them that they should change the overhead switch and not change the yaw damper computer. Your initial evaluation paragraph, this gives you some information on how you look into your fault. If you cannot detect the fault right now, then the task cannot isolate the fault, and the initial evaluation paragraph will say that there is an intermittent fault. Intermittent fault. If you have an intermittent fault, you must use your judgment and your airline's policy to decide which maintenance action to take. You monitor the airplane to see if the fault happens again on subsequent flights. But you as a mechanic, you're probably not going to sit and look in the computer and see if the fault came back again for several months. Keep checking, keep checking. Hopefully somebody else will check that, because most of the time the mechanic, if he signed off that the fault went away, then he doesn't bother to go back and check to see if it comes back again. He's got hundreds of other airplanes to worry about in the airline, and just monitoring one airplane usually is not on people's top of their list. So intermittent faults might happen because as the plane's flying, it's vibrating. Perhaps this wire is short-circuiting to the structure, and it won't do it when the plane's on the ground because there's some space, but when it's flying, perhaps there's some vibration and you can get intermittent short. Another thing that can happen is you go flying and you have a fault in channel A. Some things have channel A, channel B circuits, so you have some redundancy. Quite often they have things that on the engine. If it fails on this flight, the fault is in channel A. Channel B means you can make another flight. You can get the airplane somewhere else. But what happens is if you have a fault in the flight on channel A, you do your troubleshooting and subsequent engine run on channel B, you're not going to get the fault. The plane will go fly again, and now channel A is active. You get the fault 2.5 hours into the flight. The plane turns around, comes back to Newark. Intermittent fault, you have to be very careful. You have to do some thinking. Fault isolation steps. Your fault isolation manual task steps are presented in a specific order. The if, then statements will guide you along a logical path. Note it says, if you do not plan to follow the FIM task exactly, make sure that you read it before you start to isolate the fault. Some FIM procedures start with important steps that have an effect on the other steps in the procedure. So if I go and I say my parking brake, I'm not going to go to the first step, which is put nitrogen in and look for leaks. I'm going to jump to step 3 and look perhaps at the accumulator itself being bad. I still have to read everything through, because maybe something in the step 1 that I'm going to disregard, it might have an effect on what happens in step 3. Fault isolation manual is arranged by you have an observed fault list. This gives your alphabetical list of all observed faults. Gives a fault code and a FIM task number for each fault. This one's in alphabetical order. This observed fault list is in system order, order of what ATA system. They have a cabin fault section as well, cabin fault index. So in your ATA chapter for 21, it says 21, how to use the FIM, 21, fault code index, maintenance manual, maintenance message index, and then you have your tasks. So this section right here, 32, how to use the FIM, this one page that they have here, this would be up at the front of the AMM in your introduction, telling you how to, sorry, in your fault isolation manual, in what we like call ATA 00 front matter. And then in each subsequent ATA, they have another section where they give you information, such as this maintenance message index, where I'll say, oh, heads up display, oh, that the HUD, that's going to be in ATA 34. So then you go and you look for that chapter. They don't do this in the AMM, as I say. They don't do this in the aircraft maintenance manual, where they have a list of different things and different parts of the aircraft that are not contained in ATA 32. They only do that in the fault isolation manual. I'll get you guys something else here to look at. Now this manual, unlike a lot of my stuff where it says XYZ, so on and so forth for fake airlines, this one here is for Thai Airways International. So this is a manual that you guys might get to see, but possibly for a different aircraft type because the 737-400s are for sale right now. The auction date to bid on the aircraft was the 15th. I think that was the deadline to put it in the bid to buy a 737-400. System schematic manuals are a bit like a wiring diagram manual, but they give you information sometimes that is not contained in the ATA that you're working on, and I'll find some examples of this. So right here, we're in ATA 21. We're in 2150.00, left turbofan valve and ram air control. You have to watch our effectivity. This is only effective on aircraft PW161 and aircraft PW162, whatever those effectivity codes mean. So those two aircraft have this particular system installed. So up here at the top, they're showing us this right here. They're telling us we would want to look at wiring diagram 2164.01, although the page we are on is 2150.00. You'd also look at the wiring diagram for 2150.00, same as system schematic valve. But in this case, with this item right here, they're also telling us to look at wiring diagram 2164.00. So here we're looking at a combination of some of the wiring and some of the physical components that are in the aircraft. This helps a lot more for troubleshooting. So we're in ATA 21. Then they're showing us that we need to look at something in ATA 33 in conjunction with this L212. L2, the L means light. So in this particular system schematic, this item right here is a light. Indication light, left ram door full open. So if the left ram air door for the air conditioning system is fully open, L12 will illuminate, show that it's open. If we want to find a replacement part, L12, we can take this and go to ATA 91, which is aircraft charts. We can put this item number in, and it will give us a part number. We'll actually be able to get a part number from there instead of having to go and look through the illustrated parts catalog for page after page of diagrams trying to find a part number. This P5-10 air conditioning module, that's on the P5 overhead panel in the 737. First officer can reach up. This is above the first officer, air conditioning module. These switches and this indicator will be above him. The light, ram air door full open, is right here. Ram door full open. So we see an image of what the panel actually looks like. We have the electrical cross section of what the schematic for it looks like. And then we have an actual illustration of what the actuator looks like, the ram air door actuator. It has a switch. Then the switch will cause the light to come on. They do tell us to look at 216401, which that wiring diagram will give us more information about this actuator. The diagram we're in now, 215100, we're looking at the wiring for the light. This is sheet 1, this is sheet 2. If we print these up, we could actually use a piece of tape, tape the two together, and it would make more sense. What I'm describing here is the fact that the page isn't long enough. So right here, where we see this A, B, C, D, E, F, those lines, they go to the page 2, and then you follow the logic. So basically, if we could display two pages side by side, it would make more sense. You'd be able to interpret this better. If we were on Internet Explorer with this, we could probably get it to display the two pages side by side, the two-page view. So here we have sheet 1 and sheet 2. And your A, B, C, and D are here. So you can say from your circuit breaker here, you can follow your path of electrical impulses that will come down and eventually go through one of these paths and go to your next page, page 2. So if you're doing this in a computer, going back and forth between page 1, sheet 2, sheet 1, sheet 2, it's better if you could print them and you could just hold them side by side and be able to look at it and say, okay, makes more sense. If you have a printer, print these up and take them to the aircraft with you. Wiring diagram manual sometimes also does this, where you'll have a wiring diagram, but you'll have to have it over the course of 2 or more pages. So on the engine starter system, sheet 1, they're showing the electrical side of things. But this is a bit different than the wiring diagram manual because there's a shading that's done here on some of these. Not necessarily so much the shading, but you look at the wire numbers that are next to them. But right here, this APU control unit, the FADEC, the M1459 electronic temperature control unit, these components are in ATA 49, which is APU. These items right here, this M278 missileless switching module, this is an ATA 49. This is APU. But we're looking at engine starting system, which is ATA 80. So they've shown us electrical items that are in ATA 49, even though we're doing aircraft engine starting and not APU starting. So these items in ATA 49 will have an effect on our engine starting. Are there any questions? Is anybody awake? This is what I was looking for here. Right here we have ATA 52. We're trying to start an engine, ATA 80. ATA 52 is doors. So 5270, it seems that if there's a door that isn't in the correct position, that this will affect engine starting. I haven't looked into it yet, but I'm suspecting with ATA 5270 that there are overwing emergency exits on a 757-800 or 757-400, and I think if the doors are open, perhaps it inhibits engine start. So you have to consider the fact that there are other things that are outside of ATA 80, which is usually a very simple ATA chapter, that there might be other things that might affect your engines, keep them from being able to start. So on the engine schematic here, they're also showing a physical description showing how the pneumatics, how the air flows throughout the entire aircraft system here. And specifically then you're looking here just at the starter. So basically from your APU, you have a shutoff valve that goes through a check valve, goes to the air cleaner, gets down here to the starter, to the control valve. So if your control valve for the starter, if this does not open electrically from the cockpit, you can go down with a wrench, with a 3/8 extension bar and a ratchet, and you can open the starter valve manually. You hold that open while they're starting the engine. So if you hear air hissing around down here, then you know that yes, you've got air. So it's not a pneumatic problem, it's an electrical problem for your engine starting system. So that is system schematic manual. Over here, I've got something else. Take a quick look at. The most important question, when is break time? So as I thought, it is 2:10, so we have another bit of time before break. I'm assuming everybody can hear me. There we go, yes. I know you guys can hear me, but you're all asleep. It's all right. There'll be test questions on all of this. I'm sure you'll all do very well. Since you're such a good group, I'm ahead of schedule. In the system schematic manual, they're showing a general arrangement of your power plant system. This is a very nice feature in this particular system schematic manual in that it'll direct you to specific ATA chapters where you need to be. So with this one here, they don't do this in the maintenance manual. It'd be nice if they did. They don't do this in the fault isolation manual. This is the one place that you'll find that they're kind enough to show you something like this and tell you, you should look at 751100, you should look at 7721, look at 74 for your engine exciters, that's for your ignition. Power management control, 73, ATA 73, that would be your fuel system. Oh, hang on a second. I see that we need to fix this here so you can see this. I think we've lost our sharing. Let's get this back up again because it's not showing properly on this other computer here. There we go. All right, so as I said, this is not something they do in the aircraft maintenance manual. They have it in the system schematic manual. System schematic manual is primarily for troubleshooting, and it's really the best thing that you have to help you with troubleshooting. It's even better than the fault isolation manual because there's a lot more description of things that fall into different ATA chapters of the aircraft. Keep in mind, whoever writes the FIM, he may be saying to himself, oh, I just need to write this one section of this manual, and that's all he knows about, and he'll just write what he was told here, type this up. But the person doing the writing of the fault isolation manual may not have any mechanical experience. forget even having a license or a degree. They may just be a technical writer, so they may not really understand the system they're working on. But your system schematic manual has been put together by people that are experts. So this is a very good and powerful manual to help you. Like I say, I've seen very few other technicians bother to use the system schematic manual during my career. They usually just go and they change a box, they sign it, the plane off, and they send it off into the wild blue, and they managed to make the fault disappear. But they didn't really go into it and try to make a permanent correction to the problem with the airplane. They just tried to sign it off and get back to the couch. So this is very useful if you don't know what part of the maintenance manual to look for help on how to fix a specific problem. It'll give you an idea. If you come to these diagrams and you look, it will tell you where to go. So you're working on the engine, starter control valve, engine won't start, well, that's ATA 80. Fuel pump, ATA 73. Magnetic chip detectors, you'll be working, taking them out a lot at your new jobs when you go work on 737s. ATA 79, magnetic chip detectors. So this is a very useful manual in that it gives you a lot. Even if you're just trying to study the systems, if you want to become a licensed maintenance engineer or even become a pilot, this is a good way to understand your aircraft system, just to look at the system schematic manual. Primarily for troubleshooting, but it's also rather good as an educational tool as well, because you can kind of understand how things work together. So we've talked about a bunch of different manuals. Maybe it all runs together. So I've got another document here that will show you a little bit of everything so you can understand some of the differences between the different manual systems that you have. That way when you guys go to do your presentations, you'll be able to pick some good sources of information from each one of these manual types. So you can do good presentations and get good grades. Can you say 16,000 bucks every day, each day, every day? $16,000. You know, that's twice as much money as the Prime Minister makes. Just to ride on the airplane, fuel it once in a while, walk around, change a tire. My biggest nightmare will be, how do I clean the windows on a 747? That's going to be my biggest headache in life. Because unfortunately, if you're in the cockpit on a 747, you can't open a window. You can't get out and wipe the window down. So you actually have to get a truck or a lift to go up to get to the window to clean it. See if I can do this, what the limitations are on our software with this thing. What can I actually manage to accomplish? Open this. Does anybody know what this is? Is anybody awake? Can you hear me?
Yes.
That is 16,000 baht every day. So every day that I'm on duty, available to fly, if I don't fly, I get 16,000 baht every day to be a flight mechanic on Atlas Air Cargo 747 freighters. Atlas Air Cargo is also going to receive the last 4 747s that will ever be built. They ordered them in January, so before Boeing shuts down the production on these aircraft, they're going to build 4 more brand new for Atlas Air. Hopefully I'll get to work on those. The new airplanes will be 747-8 series. I've only been told I'm being sent to school for 747-400, so I don't know whether or not I'll get to learn about the 747-8. Maybe I don't get to see them for a few years, but eventually I will get to see them for 16,000 baht per day. And honestly, that's not very much money for the type of work I'll be doing. But at this point, I'd be quite happy to take 16,000 a day, even though it should be instead of $500 a day, a job like that should be $800 a day. But I just have to take what I can get. So here we have a training book that I put together for the CFM56. It's 14,000 pages long. I tried to take every maintenance manual reference, every training reference, any other books that are not part of Boeing's publications, anything for the 737, for the CFM56, and make one document out of it. So there's a company called Flight Safety, and unfortunately, it became Flight Safety Boeing. I say it's unfortunate because the way they did textbooks was different than what Boeing does. With this training book that they did for China Southern Airlines, don't see the publication date, but I think it was about 2003. This particular training book, this school that they put together, they mix ATA chapters into things that go together very well. So ATA 71, power plant, ATA 72 engine, these things make some sense in being taught together. Power plant, they have the engine drains. It's interesting they'd be in 71 instead of 72. Your fan cowling would be in 71 because that's not part of the actual core engine. So what goes into 71, what goes into 72, it will be different on every airplane type that you work on. Some airline manufacturers will not have an ATA 72 at all. Some of the older airplanes that just had everything all in just one power plant reference in the book. They didn't split it up. They figured if it's hanging on the pylon, it doesn't matter if it's cowling or if it's a fan blade. They just put it all in one chapter. But a lot of people in their publications, they'll make it ATA 71 and 72 as two separate entities. ATA 77 is engine indicating. So it makes sense to teach 71, 72, 77 all together. It makes sense to teach them all together in the class. And then that's what their books look like. It says Flight Safety Boeing on this. Some of the other ones had different brand names on it, but the publications were different. The content was different. So that's one form of GenFam, General Familiarization class that you could take. This is a training manual. It's marked as a training manual. It's not part of a maintenance manual. But then Boeing, in their infinite wisdom, decided to make this. And it says Aircraft Maintenance Manual. Only thing is that this is a training document. It may not contain the latest information. It may not be as up to date as your real, true maintenance manual. So Boeing has an AMM Part 1 and an AMM Part 2, like a Volume 1, a Volume 2. Part 1 is Systems Description Section, SDS. You're not allowed to use this SDS, the System Description Section. I can't go out and work on the real airplane and be looking at this and reading it and then working on the airplane, using this as my guide on how to fix the airplane. This is illegal to use, unsafe as well. It's just for training, for systems training, like we're doing here in the classroom. We're not flying a real airplane. It is printed in landscape format. The real maintenance manual that you use to work on the airplane is printed in portrait format, not in landscape. So if you see somebody who's out there working on an airplane and the print is here in landscape format and they're working on the real airplane, they need to go and pull up the same information, same ATA chapter, but from the actual book that is printed for working on the airplane. So the difference is that this is portrait format, this is landscape format. This is the fault isolation manual. This is legal to use on the airplane. This is your parts catalog. This is a power plant buildup manual. We'll get into a little bit more of these in depth after break. This is your the true aircraft maintenance manual, your practices and procedures, maintenance practices and procedures. Power plant adjust test. This is something you can use to adjust and test the engine. This is a legal document to use for actual work on the engine and for signing off the logbook to say, yes, I fixed the airplane. You can say I performed test number 3B, part power leak check, in accordance with Aircraft Maintenance Manual 71-00-00, test 3B, 71-00-00. This manual here, it talks about gun all. Gun all. Gun all. Oh, what does this mean? Anybody? Shotgun, M16, revolver? What's this gun? G-U-N. This is what I was telling you. You have to be careful about making sure that you have the correct airlines manual. If I was at UAL, United Airlines, it would say UAL. Continental Airlines, it would say CAL. Thai Airlines, it would say TII, Tango India India. So this gun, GUN, it's down here as well, D633A101-GUN. Be careful, because I've worked places where people had access to multiple different types of manuals. They would go to the wrong book and print up the manual, and they're out working on the airplane, and they're working on America West on that airplane. For America West, it's an airline that's not there anymore, but they printed up a maintenance manual reference from Continental Airlines because they found the Continental Airlines manual in the computer. They pull up the stuff, they print it up, and they're out working on the airplane. And you can find that the instructions that are in the Continental 737 manual and the instructions in the America West maintenance manual are different because they might have different part number, different effectivity components installed. Continental might have service bulletins that have been done, and America West may not have done the service bulletins yet. So the aircraft will be completely different. You have to make sure that you're using the correct airlines manual. This is China Southern. We're not working on China Southern airplanes, so therefore this manual would not be good for working here in Thailand. So if we're going to run an engine for an airplane China Southern, it would say GUN. Continental Airlines would say CAL. If you're going to do a power plant task in your maintenance, in your sign off in the logbook, you're probably also going to be required to say that you performed not just 710000, but you'll actually have to say the entire number, the entire task number. So 71000800-811-F00. That's not an O. They don't use the letter O in any of these references to avoid any confusion. They also will not use the letter L as in Lima, because an L might look like a 1 by mistake. So they avoid the use of the letter O or the letter L. We had an index file installed on our computer. We hit that, it would take us to that particular figure. I don't know where that's taken us. In this case, it actually worked. We did go to the right figure. A lot of the manuals won't take you to the figure if you click on the index on the link. This type of a document. This is the engine manufacturer has made a engine removal and installation training course. Again, this is a training document only. If you were out changing a 737 engine and you're using this on the computer when you're working on the airplane, looking at the answers during your test on a piece of paper, or looking at the palm of your hand because you wrote things down, you cannot use this when you're actually working on the airplane. Not an official document. It's not approved for maintenance use. Something to use in the classroom to discuss some different things. But when you go out and work on the airplane, you can't then go take this out of your toolbox using it to work. Training purposes only document. This document here, you probably would not have access to. This is the CFM 56 shop manual. Usually you would have an engine shop. They would have access to the shop manual, but on the flight line, technicians usually are not given access to the engine manufacturer's flight manuals. This one's just talking about removal and installation of the engine from a maintenance stand. The only reason you would be removing the engine from a maintenance stand as such is you're going to take it, hang it up in the shop, and disassemble modules. So day-to-day operation for the actual mechanic out of the flight line or even in the hangar, you're probably not going to use this reference, but it's an example of what the engine shop manual looks like. This engine would be the engine for 737-800, the next generation, the NG, and your 737-400 would have used the Dash 5. 767-400 series would have had a Dash 5. Power plant build-up manual cannot be confused with your engine shop manual. Engine shop manual, engine overhaul manual is how to overhaul the engine. Power plant build-up manual, though, is a Boeing document, not the engine manufacturer's document. And what it's for is, there's a term called QEC. QEC means quick engine change. So if you send your engine back to overhaul at CFM, there's usually a lot of things you're going to take off and keep off on the side in a box because they're yours. They're airframe components. They're not part of the engine as far as the engine manufacturer is concerned. They're things that were provided to Boeing to install the engine, but they were not built or manufactured or supplied by the engine manufacturer. So QEC items are in the power plant build-up manual. Power plant build-up manual does not tell you how to change the fan blades or overhaul the engine or remove any huge major components from the engine. That's covered elsewhere. This is only for some small things that are part of the QEC, quick engine change. Gives you some dimensions on the engine, how there's certain things that this will help you if you're shipping the engine. Yes, you need to know how big it is for the trucking company. So they have instructions on how to use the manual, but we'll get back to that after break. So for those of you who are paying attention, it is break time, break time, break time, break time. Take a break. And I know nobody is paying attention. Okay, time for us to get back to work. Time for us to have more echo, 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 echo. Good. Everybody should be awake now. Unfortunately, I've got two laptops next to each other, and the nicer laptops that the director and I use, the Windows 10 laptops, they get this strange echoing effect if we're trying to use it and there's another computer logged in nearby. So I'm using this other computer off to the side to monitor to see what exactly you guys are seeing, so I can tell whether or not you're actually seeing the same page that I'm seeing. Because otherwise, if I'm looking at just one computer, I don't know whether or not you can actually see the same manual. So I've pulled up the wiring diagram manual for China Southern Airlines. Control F. It's in the document here. F. So you'll notice here that they have in their effectivity chart here, they have GUN, this interesting gun that we saw before, GUN, GUN all, that's 1 point. So their airline, it looks like maybe what they had before is maybe they own some airplanes, but they've given them to somebody else to operate. So in their effectivity code here, they have an XIJ. So you wouldn't use, you'd have to be careful with your manuals to find out whether or not you can use a GUN manual on an XIJ airplane, most likely with the way Boeing publishes these. If you're working at China Southern and you have aircraft 101, 102, 103, then this manual would be legal to use. Otherwise, you'd end up having to get a manual that's actually specifically marked for XIJ, whoever that is. They probably got some airplanes from somebody else, is actually what they probably have here. Most of their airplanes all say GUN, but there's a couple that say XIJ, X-ray India Golf. They're still Chinese registered aircraft. This B-5233, that means it's Chinese registered. Even the serial numbers, 35361, 35362, 35364, and 35368, they were all built at the same time, but for whatever strange reason, they've got a mixture of XIJ and GUN. So there's two different air carriers here, XIJ, GUN. So if I was quality assurance somewhere and you're working on an airplane that is in this effectivity block, if you're working on this airplane, Bravo 5233, out of curiosity, let's see what it looks like. See what the paint job looks like. It still says it's China Southern Airlines. Looking on the internet, see if you can find a picture, and yeah, the airplane says China Southern Airlines on the outside. So I do not understand what the identification, operator identification code is, XIJ, X-ray India Juliet, instead of GUN, because all of the manuals that I got from China Southern are all marked GUN, but you'd have to watch this code, and that's that code that keeps popping up in the lower left-hand corner of your manuals on the page, in the lower left-hand corner. On it. Here. So this manual here has one of these airplanes that's not GUN. Sorry, well, we get to the bottom left-hand corner of the page. This one has YJ695, YJ699. So in your effectivity, you have to be careful to make sure that you're using the correct diagram for the aircraft that you have, because in this auto throttle system, perhaps one airplane has things in it that are different than the other. Unlike our system schematic manual, you'll notice that all we have in here are wires. There's no depictions of any of the components, what they look like. There also, if we're in ATA 23 with these wiring items, we're not going to see things that are in ATA 52 or 43 or 21 or 25. We'll only see the wires that are in this ATA 22 part of it. So wiring diagram is a lot more specific, gives a lot more information about the wiring circuit. On our system schematic manual, we did not have the wiring numbers. Every wire on this Boeing 737 will be marked. The wires are almost always white. And on the wiring, there'll be black printing. And it will say Whiskey 2175-0014-18. So this is an 18 gauge wire. This is a bit heavier of a wire than most of your wires in the aircraft. Most things are 24 gauge wires in the airplane, 22, 24 gauge. That's usually all you need. But this 18 gauge wire needs to carry a bit more amperage for whatever the system is that it's operating. It's also 7.5 amps, the circuit breaker, 7.5 amps of 28 volt DC. So if we had 2.5 amps for this particular circuit, then we would only need to have 24 gauge wiring. P18-1, that's the load control center left. This manual, I can tell, was probably originally a paper manual that got scanned into digital and then got converted, because that is the number 0. That should be LO as in Oscar, AD, not L0AD. So that seems that the scanning device scanned this document in and misinterpreted the letter O as being the number 0, but that should be the letter O and not the number 0. In wiring diagram manuals, in Boeing's logic, in the diagram up here in the top left corner, you can see the mouse moving. That's where your power is coming from. Your circuit breaker is there. So all of the wiring diagrams, they start with the power up in the top left or on the left-hand side of the page, and then the power moves towards the right-hand side with the way that they draw all of their diagrams. Sometimes it's necessary for them to take it then and go from one sheet to a next sheet, and you just see the lines will stop, and then it will give the identification number on which line you would pick up on the next side. Usually they say A, B, C, D, E, F. Those letters have no corresponding relationship to what the wire markings are or anything else on the aircraft. It's just something for the diagrams, you know. You go from A over here to A over here, that you're making the wiring diagram make sense like it's one sheet instead of two. So on our P18-1, this is a big circuit breaker panel. There's AF, CS, AT, DC1, auto flight control system, auto throttle, direct current 1, DC1, 7.5 amp breaker, circuit breaker. We could come here to this Delta 41803P as in Papa. This is a Cannon plug. We can disconnect this from the circuit breaker load control center. We can disconnect this Cannon plug. We can then go to the wires with a meter and we can do some checks on the wire. So we could check right here at pin 14, pin number 14 at Delta 41803. Now, if we're looking at the wiring coming out of the load control, we disconnect the Cannon plug, we move the wiring here. We're actually looking at Delta 41803J as in Juliet. J, that is a junction. I think this would actually stand for Jack. Jack and then P for plug. So if you're checking at the voltage, you're on J14. If you're checking on the wiring bundle, checking for continuity or something going out this direction. If you have this connected, you won't be checking for voltage anymore because you won't get any power. But you can check from the Cannon plug all the way to somewhere else on the aircraft and see if it's short-circuited or if you have an open circuit. So you could look specifically for this wire if you think this wire has a problem, and you can replace that one wire, or you can check along that wire and try to figure out if it's got a break, if it's broken. You actually have some equipment you can hook up to the wire. It'll send a signal down the wire, it'll bounce back, and it'll tell you an approximation of how many feet you'll have to go back into the airplane to find out where the wire has been broken. So if somebody went and they cut the wire by mistake when they're doing some other maintenance, and you try to figure out on this whole airplane, if it's 150 feet long, this wire, where is it broken? You can send a signal down, it'll bounce back, and you'll have an idea of how far back in the airplane, maybe in the cargo pit or the overhead area and above the seats, where you're going to go and look to see if you have this damage. So if we follow the wire, going back away from the circuit breaker, if we were not getting any power, if we checked here at the circuit breaker or here, and we found we weren't getting any electric power out of the circuit breaker panel area, then we'd have to look at wiring diagram manual 246121, 28 volt DC bus number 1, find out why are we not getting any power up here to get to the circuit breaker. Circuit breakers, by the way, they're in the system to open the circuit before the wires begin to smoke, before they emit smoke. FAA question, circuit breaker opens the circuit before the wires emit smoke. You're trying to prevent your wiring from overheating. You don't want the wire bundles to catch fire. So the circuit breakers are there to prevent electrical fires. So if we follow our wire, W21750014-18, we follow it along, then it goes to another plug that attaches to another jack, Delta 41821P. If we wanted to find out where in the aircraft this is, in ATA 91 aircraft charts, we do have a section in 91 where it will tell us what station, what location in the aircraft we would have to go to find this cannon plug so we can disconnect it, troubleshoot the system going back up to the cockpit. Maybe if we have an open circuit, then we know this wire is broken somewhere. We'd have to try to find the problem. If we couldn't find out where the wire was damaged, we might even go as far as installing a new wire in the aircraft and replace this wire. And then you can put a pin in this side, a pin in this side, and replace it. And then if you do that, you'll take some heat shrink. It's a tubing that you're going to heat up with a heat gun, and it'll shrink down onto the new wire. You write the wire number. So if you wrote in the wire number, you would probably be told that you're going to have to write W2175-00-14-18, and then a note afterwards saying that it's a repair wire. So if you had to, in a bad situation, if you had to take this wire out here, then you would then probably bend the wire back and then put heat shrink over the existing pin, heat shrink it, and you would stow this wire. You would keep it there. You wouldn't be able to rip it out of the bundle because it might be several feet long, might be 100 feet long to go through all the way. But I have seen cases where people have installed a replacement wire, a repair wire, to be able to take the current, let's say from pin 14 here, all the way to another component at pin F as in Foxtrot. But you would then want to make some kind of an identifier on both ends of the wire so somebody can find it again in that wire bundle if they have to go and check voltage or continuity or check for a short circuit, and make some notation that it's a repair wire, not a factory wire, but it's a repair wire. Incidentally, you cannot make replacement parts for Boeing, but you can make repair parts. Fabricated repair part in accordance with, you'd have to have a drawing, some specification. So one place I worked at, we had people that could make hydraulic tubes. We had the capability to fabricate high pressure steel hydraulic tubes. So if we had a damaged Boeing tube, we would take it to the shop. They would fabricate a repair tubing repair tube, and it would be noted in the maintenance record that we fabricated a repair part for the aircraft, and then it would be marked as such. We wouldn't put the Boeing part number on it. We put in a part number for our own repair station. So this wire then, the voltage would then go through pin F on Canon plug D41821P as in Papa. And on the other side, for simplicity, they have not put the number, but the identification for this jack would be Delta 41821J as in Juliet. Then the wire goes in this area of the aircraft, and now you notice the wire number is different. 030-18. It's still an 18 gauge wire, but it's not a Boeing wire anymore because there's no Boeing number on here. It just says 0300. So this is an internal wire and some component that's installed in the aircraft that's supplied to Boeing. It's not part of the airplane. It's something they've purchased and installed. So it's in the E1-1 shelf. So it's interesting that these wires do not say Whiskey 2175-00. Actually, they might. If you actually look at the wire itself, it probably says Whiskey 2175-0030-18. In this manual system, they may have just omitted the first 4 digits of the wire number, because I think your E1-1 shelf, E1-1 shelf, this item that we're looking at, I believe this is internally manufactured by the Boeing Corporation, not bought from an outside vendor. So E1-1 shelf. This will be in their electronics bay. This is one of the racks where they have all of the computers, and this is going to be behind the cockpit and then underneath the floor. We're going to an M1875 Flight Control Computer A. M stands for module, W stands for wire, P stands for plug, J stands for jack. M1875, this is going to be a large electronics computer. It's going to be worth a lot of money. It's easy and quick to change, this flight control computer. But you want to troubleshoot before you go and order an expensive part like this. You want to make sure that it really is the flight control computer and that it's not a wiring problem or a relay. In this case, there are no relays in our system on this part of the wiring circuit. From here to here, there's no relays. This is auto throttle servo motor number 1, M1836. But we do have to take into account that there are some things that they're not illustrating on this figure that could cause us some problems. So this computer here, we're only seeing things that are in our current ATA, this wiring here, but then ATA 73, ATA 34, ATA 22 all have things that are feeding into our flight control computer here. ATA 22 is auto flight. ATA 34 is navigation. ATA 73 is engine fuel control. So we have various things that are communicating back to this computer as well, that there could be problems with those systems. And a problem might not be in ATA 22, which is autoflight. ATA 22 is autoflight. But we have some things from 34, navigation, and 73, which also feed into our flight control computer. System schematic manual will show things that are outside of our ATA, so it might also show some wiring and other information that feeds into the system in the system schematic manual, but the wiring diagram manual is only focusing on the wires that are just associated with this part of ATA 22. Didn't focus on everything in ATA 22 because in this list down here, there were some other wires that were ATA 22, but for simplicity, they've carried them over into a different part of our system. So MCP3 Mode control panel. This is for the autopilot mode control panel. It's underneath the glare shield. This is where the pilots will dial in the airspeed that they want, the heading, so on and so forth. They engage the autopilots. Auto throttle switches are there to engage auto throttles. So ATA 221151, that circuit is illustrated somewhere different than this ATA 223131. So wiring diagram manual is very good for specific information on the wires themselves, the connectors, the modules, the racks. Doesn't show the overall operation or everything that affects the system you're working on. This particular wire has a symbol on it, which is of interest. I would suspect that these wires might be, doesn't say. I would suspect though that these wires here, these two wires, are alternating current. They could be direct current, but this right here, this circle, and then this line that goes to a ground. This indicates that these two wires go together with their plastic insulation on the outside, and then there's a metal jacket around them, metal shielding, a braided shielding. And that shielding is then grounded to ground. That'll take any stray signals or noise out of these wires, and it sends it to ground. This is mostly done to prevent any kind of noise, radio interference, such as this. This type of noise we hear now. That's sort of what you would get in an airplane if you did not have shielded jackets on certain wires, because then the wiring, the voltage going through that wiring then will cause interference and noise in your aircraft. Some general aviation airplanes that aren't very well maintained, if you get your license somewhere, you rent airplanes, as you're sitting there with your headsets and you move the throttle up and down, your RPM goes to takeoff power, comes back down to idle power, up and down. You'll hear in your headsets, you'll hear a buzz on your radio as you're flying the airplane. And this tells you that somewhere maybe one of these grounds is broken or it's not properly shielded. So this is a shielded pair of wires. Two wires that are running along through a long, flexible metal outer jacket. This metal outer jacket then has plastic on the outside of it. And then you can take that metal jacket and you ground it. So any stray electromagnetic interference that you might get off these wires then gets just taken and grounded to the airframe structure. Usually you'll find grounded wires in a lot of them in ATA 23 communications, because a lot of your radio system components you don't want to get weird noise and feedback and strange signals. So you then use shielded pairs to ground the wires. It's kind of cool. I can wake you guys up this way. I know some of you are sleeping. You'll notice on here too that they show the shielding, and then it goes to the plug, goes to the shield. It's shielded. These wires have, you take the metal shielding on the outside and you solder on another wire and take that to ground. There's electromagnetic shielding, and you do that at both ends of the shielded pair. It's a little bit redundant, but they ground it at both sides. So this one's being grounded at the plug itself. So you'll find that the extra shielding wires will come off and they'll just attach to the cannon plug itself. Usually the cannon plug's got a few pieces that are held together by screws, and you see some of these little wires that come up and the screws go through them. And that's basically just to ground out some of this potential source of noise. TB, Tango Bravo. TB, not like TB9 or TB20 or tuberculosis. TB is terminal block. Terminal block, you have a bunch of wires that all come together, and there's some screws that stick out the nuts, and you tighten the nuts down, you have a bunch of wires that all come together on a terminal block. If people remove and install wires from a terminal block, there's a very, very light torque on these wires. But when people do modifications, they'll take a wrench and they'll put Godzilla torque on the nut. And then that cracks the terminal block. And you get short circuits jumping between the different studs. This will cause intermittent faults in flight. You'll have different warnings on your ICAS. Then when the plane's on the ground and you don't have a lot of vibration causing the short circuit, you don't get the indications on the ground. So you sign the airplane off, you think it's fine, then it goes out over the Atlantic, and then all of a sudden you have 5 ICAS messages. And the airplane turns around after 2.5 hours and it comes back to Newark with unhappy passengers because somebody over-tightened a nut on the terminal block, causing the terminal block to crack inside, and then you get a short circuit. A little bit of stray voltage jumping between pins, and then you end up with warning messages that are fake messages, but scare the pilots and they come home back to Newark. Happened to me one day. Plane came back again because somebody had damaged the terminal block, and these fake messages, these intermittent messages came back, and when they got the 5th message come back again, they decided that they were going to come back to Newark. So somebody had over-tightened the B nuts on the terminal block instead of using a torque wrench. You're supposed to use a calibrated torque wrench, and it's a very light torque. So what else can we find exciting in our wiring diagram? This copy doesn't want to go to the bookmarks. There are bookmarks for this document, but this version is not going to go to the bookmarks. Okay. Service bulletin list. We have a list of service bulletins in this wiring diagram. So this list was on September, oh my goodness, September 9th of 2011. I thought this book is more recent than that. So they had service bulletin 21-1135R01. So this is an air conditioning service bulletin, ATA 21. R01 means revision 1 of the service bulletin. Boeing will put out service bulletin revisions. So most often you'll see the designation will indicate revision 01, which means they put the service bulletin 1 out. They never had to republish a new one. And by September 10th of 2009, they have started these service bulletins on effectivity YC027. They've started the service bulletins, and they're working on these different wiring diagrams. So these wiring diagrams, at some point, when the service bulletin has been finished, the wiring diagrams need to be updated, but it might take a while for somebody to provide updated wiring diagrams. So you may have a temporary revision binder. You have to look at your temporary revision to see if you have to look at a different version of this figure, different revision of this page. And then the subject of that wiring is air conditioning pressurization control. So this is one service bulletin that they have, one example of one of the service bulletins that are in the service bulletin list. There was only one aircraft that was affected by this one particular item, but then this other service bulletin, 21-1177 air conditioning pressurization control system. They're changing the power source to the pressurization system circuit breaker. That affects a large number of their aircraft, very large number of their effectivity aircraft are being covered by the service bulletin. So if you're working on 21-31-23, 24-61-24, these wiring diagrams, at some point, the diagram configuration will change because once the service bulletin has been incorporated, it means it has been finished on that airplane, then you'd have to use a newer revision of your wiring diagram. ATA 21, 20, 21, 31, 23, this is air conditioning. ATA 2461, this is in the electrical power system for the aircraft. So your power supply to your your ATA 21 system, you're going to be changing something in the power supply that goes up and then comes into the circuit breaker cell. That sounds like an expensive service. Are there any questions? If there are questions and you're shy, you can ask me on Facebook later on, so you don't have to ask during class. And you can send me a message anytime, 24 hours a day on Facebook. If you're trying to figure out where in the wiring diagram you would have to look, you can look at this next page. So here they're listing some of the items. This one's a numerical listing, mostly numerical. No, maybe not. This is probably alphabetically listed. 115 AC ground service bus. So if you're on the ground, you're not running the engine, you're not running the APU. The terminal is providing you with power through an external power port. You'd want to look at figure 245211. So this page here, this alphabetical index, it's one way for you to try to figure out where do I have to go in my system. See if we can find anything about our air conditioning again. I'm looking here instead of looking in ATA 22. Next. Sorry, not 2221. So looking at our alphabetical index, there is something here from ATA 21, air conditioning. So it gives us a bit of a reference to figure out where we have to go. So cabin air recirculation system, 212511. So the alphabetical list kind of gives you just a bit of an idea of where you would have to look. And beyond the alphabetical list, then we have our general information. This is like the thing we looked at the other day where we were looking at how to use the manual in 00-info in your front matter on both the A320 and the 737, how to use your aircraft maintenance manual. On the front of your wiring diagram manual, they tell you how to use the wiring diagram manual. An important note is this wiring diagram manual is applicable only to those Boeing airplanes listed on the effective aircraft page. So you would not want to try to use the aircraft wiring manual from Thai Airways if you had an airplane from Continental, because a lot of times the wiring is completely different. With Continental Airlines 737-300s, if you went into the cockpit panel was completely different from other people's 737-300s because Continental wanted only mechanical instruments in their instrument panel. So the training would be the same for 737-100 and 200. Excuse me, if they went to fly the 737-300, they wouldn't need a separate rating on the license. So Continental Airlines spent $30,000 extra per airplane for 737-300s that did not have any kind of digital CRT screens. So they kept an old mechanical cockpit on 737-300s, even though other people were starting to get some things in there that had cathode ray tubes instead of having old mechanical instruments. So your wiring diagram manual is really out of all the books, it's the one book that it's very specific from one customer to the next, that you really cannot expect to use a wiring diagram manual from General Electric's leasing company, be able to use that on, let's say, a Virgin American aircraft. With the size of these volumes, I had a bunch of discs upstairs, DVDs. Some airlines, their wiring diagrams, 8,000 pages. Other airlines' wiring diagrams are 5,000 pages. And this is in the same year. So you have to be very careful to make sure you have the correct effectivity and the correct manual. And here they mention this ATA specification number 2200. Your Boeing wiring diagram manual is written in accordance with this ATA specification 2200. And now they have an iSpec 2200i. And what that then does is it says, if you're going to write a maintenance manual that's only going to be used on the internet, then it's going to function differently. It functions more like it's a web page that people are working with, and less like a PDF document. This is a PDF document we're working with. It's normal, it's sensible, we can print it up, everything looks nice. And then some of the internet stuff, when you print it up, it doesn't look the same when you print it as it looked on the computer screen, because things are going to space differently now because you're going from a web page look to printing it on a piece of paper. And they're mentioning here your system schematics are in a system schematic manual. We've looked at the system schematic manual earlier. If you're going to do troubleshooting, use your fault identification manual. And then also your system schematic manual, you should be using that in conjunction. Those are your first two manuals I'd recommend. And then number 3, you should be using your wiring diagram manual and then your aircraft maintenance manual as well. That system schematic manual, if you have a chronic problem that keeps coming up over and over again, pilots keep having the auto throttle not work, and then the first officer's airspeed indicator doesn't work. If this has been something that has happened many, many times in the previous months, it would be good to take the system schematic manual and do some proper troubleshooting. But our friends in Indonesia, they just said, oh, cleaned the connector, did this, did that, signed off the airplane saying that auto throttle works and the first officer's airspeed indication works. Aircraft 610 then takes off out of Indonesia. Auto throttle disengages. One engine's at full power, the other engine backed off to idle. First officer's airspeed indicator probably wasn't working again, and if he was the one flying the airplane, he may have stalled the aircraft, put it into a spin, and they've destroyed one of Continental's former aircraft in Indonesia because people, number one, it seems like their maintenance people just didn't even bother to try to fix the airplane. And number 2, the pilots should have been aware that this was an issue before, that both of these systems were not working properly before, and they should have been monitoring it better during flight to make sure that their auto throttle was working and that the airspeed indicator on the first officer's side was working. I think they finally recovered the voice recorder and the flight data recorder, so it'll take probably 1.5 years or 2 years for them to come out with a definitive report on the cause of that accident. So customer originated changes, COC. It says Boeing will not undertake to test, evaluate in any form the validity or technical accuracy of a customer originated change. You can incorporate some customer originated changes into your manual. You can come up with something and say, well, here at Atlas Air Cargo, we come up with some changes. You can make some of your own additions to your manuals, and Boeing kind of says they're not responsible for that. But if you make a change to your manual, you come up with something that you say, yeah, we want to do this as an extra precaution at our airline, or we've done some modifications and we have this supplement. Usually you'd have a aircraft wiring diagram manual supplement, And I've seen that for some airplanes that have been modified to cargo aircraft that were not originally cargo. Then that customer airline, their engineering department, that they've evaluated and approved all of this and done something with their FAA to get it approved. It is good to send that information to Boeing, and perhaps they will also incorporate it into a future manual. But if you've done a lot of wiring changes to your aircraft after Boeing sold it to you, then that's what this is, customer originated change. Boeing didn't make the change, they didn't make a service bulletin, but you've done something different to your airplane, and now you have responsibility for that. Service bulletins are things that Boeing is asking you to do. Maybe they suggest you do it, or it becomes a mandatory service bulletin. So then those are Boeing documents. They have service letters, notify customers of unique maintenance or operational items. Service letter is more of just a notice, something you might want to consider doing more often. They could have a master change. Master change is something that there must be negotiated with an airline, with a customer, to revise an airplane delivery schedule, so on and so forth. That's a major change to something like maybe with the Boeing MAX, they have to make some changes that will affect the price and delivery time of the aircraft. That's not for day-to-day maintenance. It's just some basic things that are in your publications. Where do you find your wires, everything else? You have a station chart. So if something says LBL, it will be left of the buttock line. Buttock line goes straight up to the center of the aircraft. So anything this way, left of the center line would be LBL. Right of the buttock line would be RBL. So if it's 8 RBL, it means it's 8 inches to the right of the center of the aircraft. So if you're trying to find a particular component where it's installed, they'll give you a station, they'll give you a buttock line, and they also give a water line. Is it above the floor? Is it below the floor? So if you're looking for a component, one day I was looking for a relay on my own airplane, and it turned out it was below the floor compartment behind the nose landing gear, but they didn't give me any information as to where it was. It didn't give me any station identification where it was. There just was a very vague picture in an illustrated parts catalog, and it turned out it was below the floor and not above. Wire separation, this is an important thing when they design aircraft, but if you're incorporating modifications. Airplane wiring installations, you have to have special emphasis on separation of redundant systems. So if you have multiple autopilots in the airplane, you try not to run all of the wiring all through one particular area. As if you have something that cuts through one set of wires, it will cut through the other wires. You try to separate it a little bit, get some physical separation between components, like things that might go to your engine and cause the fire shutoff valve to close and cut off the fuel to the engine. You don't want those wires to all be in the same area. So if you get water in there and it short circuits, you don't want both engines to have the fire shutoff valve close the fuel valve and shut the engine off. So wire separation is an important feature. That's mostly for people that design the aircraft, but then also if you're doing upgrades, modifications, you want to make sure that you keep your redundant systems separate. If you need to know what your definitions are, at the front of all of your manuals, you'll have a table that gives you definitions, so you can try to figure out ADIRS. ADIRS, what does that mean? And you can come here and you say Air Data Inertial Reference Unit, Air Data Inertial Reference System. All of these airline manufacturers, they love lots of acronyms, so it's good perhaps even just to come in here with Adobe Acrobat and extract the pages with the definitions and make yourself a little reference to pick up on your phone from Google Drive, or you can print out. Okay, There we go. Finally, it works. So in chapter 91, you have this ATA 91 is considered to be charts. Charts that's very vague. And actually, there's many different types of things that they show in ATA 91 on Boeing. And all of them have a lot of information that will help you on finding where your wires are at, where your cannon plugs are at, what type of wires that you have. It gives an extensive amount of information on the electrical equipment installed in the airplane. So this one is useful that if you're looking for a cannon plug, so you can go and disconnect the cannon plug and look at wiring. This will give you ideas on where some of these items might be, where the circuit connections might be in your wiring in the aircraft. So this is showing you a physical location and then a breakdown on what components you'll find where. So in the lower P6 panel, which is an electrical power supply panel in the cockpit on the 737, you can find this at where's it in the airplane. If you forget where P6 panel is, it's in the cockpit, but specifically you're at station 260. That's the forward and aft on your aircraft. So station 260, you're coming back here to station 260, water line coming up this way, 215, it's above the floor, and right butt line, RBL040. So it's in the cockpit right about here on the 737 cockpit, which is going to look a lot like the front of this 707. So you have an X, a Y, and a Z axis for your location. Station, water line, and your RBL, LBL. Tells you where you can physically look for this component on the airplane so you can find it and do some troubleshooting. You have a circuit breaker list. So in our P6 panel, which we were discussing before, which would be on your right-hand side of the cockpit, then you're going to have your circuit breakers, and they're identified by those numbers, letter C as in Charlie, C for circuit breaker, C01453. This is for a video. It tells you what wiring diagram to look for, 44, 21, 46. What effectivity aircraft this is installed on. So effectivity is shown here where you've got different choices. We have the same item here, Delta 007. C01454. This equipment number right here, the circuit breaker, we have, interestingly, two of the aircraft, the wiring diagram is in ATA23. This airplane, they put it in ATA44, even though it's the same circuit breaker. It does the same thing. Circuit breaker for video 3. So an aircraft Yankee November 601 to Yankee Romeo 474, they decided that that circuit breaker belonged in diagram 44, ATA 44. The wiring engineers who did these other aircraft, YC922, they believe that this was part of the communication system 23. ATA 23 is communications. ATA 44 is like for a cabin passenger item. So when I worked at Continental, we didn't use ATA 44 on our 737s. So we would have the same thing on our older 737-800s. We would have ATA 23. The video system would be in there. So you can watch videos when you're flying on the airplane. You can watch a movie. In the newer aircraft, they'll put that under ATA 44. Even though it's the exact same system, they like this ATA 44 now on some of the newer airplanes. As we didn't use ATA 44 on our aircraft at Continental, but if I went back there now to United and they're getting the newer 737s or Boeing Max, they'll probably now assign that particular type of system into ATA 44. I can't remember what they call it, cabin information systems or something, but it's basically entertainment systems for televisions and in-flight movies and things like that. So that's our circuit breaker list. Now I'm in a disconnect bundle list, and this is an important one for troubleshooting. You want to find that Cannon plug so you can figure out where your trouble's lying at, and this gives you information. So in your E4-1 shelf, underneath the floor, as you go in the passenger cabin entry door, be underneath you. At position 10, they'll have receptacle Delta 41810J, J like a jack. It's a receptacle. It's in wire bundle Whiskey 0410. Your big bundles will have a marker on the outside. You look for W0410. The Cannon plug for that system would be Delta 41810P. And then that's in wire bundle Whiskey 6420. So you might have one end of the wire bundle that you've got the jack here, and then eventually you're going to trace it through and you end up in a different wire bundle, but it's the same wire that's going all the way through. And then you're going to look for this Cannon plug in the wire bundle W6420. And then they mentioned the effectivity of which aircraft will be wired in each configuration. So that is in your disconnect bracket list, where you take the interconnections. This is where you can go. You can disconnect the Cannon plug and then go find a particular wire disconnected at both ends. It's not connected to the airplane. Now you can take your multimeter and take a wire to each end. See if you get continuity. If it doesn't ring, if you don't get a tone all the way through the wire, you know you have an open wire. So you should hear something if you have continuity. But if you don't have continuity, you won't hear anything on the meter. You won't get a beep when you go into the check open. So 912111 is your wire list, the list of the wires. Now you're not looking for information on a bracket to find a disconnect. Now you're actually looking for a wire, actual wire, and where you would find the information on that wire in your airplane here. You can find a better example. So a wire bundle, whiskey 0410, wire number 0330, 24 gauge. So the wire itself, it will be printed on that wire. Whiskey 0410-0330-24. So you can actually look through your wire bundle and you can find that one particular wire. It's saying that it's in the E4-1 electrical shelf. This is underneath the floor again in the electronics compartment. It is a wire for the air conditioning system. ATA21, that's air conditioning system. And the wire goes from and to. The wire begins at Delta 41804J. This is the jack. And it goes all the way to Delta 00458 Alpha. This is the other end of the wire. And then you're going to look from A07 on the other end at 12. So you take your multimeter at A07 on one side, 12 on the other side, and if you're disconnected on both sides, that wire, you should hear a beep tone when you use your ohm meter. You should have no resistance. So that is wire list. And again, you have to be very careful of effectivity. Make sure that you have the right effectivity. Ground list. This lists where you have grounds. At some point, you need your wire to go from your circuit breaker, from the power, it goes to a component, and then you go to ground. This completes your circuit back to the airframe structure. So you have a list of ground lists, ground wires. So in bundle whiskey 0321, there's a wire 20010 Zulu. This is a ground bundle, and this is in ATA 31. It's on every airplane, effectivity all. So you'll find the same ground wire on all of your airplanes. In this other case that's down here, this wire here will be, oh no, they are different numbers, sorry. But they're effective only on aircraft YC027. So that is your ground list. There are many, many things in the charts. Actually, the length of ATA 91 is far more pages than the complete rest of the wiring diagram manual. From ATA 21 through ATA 80, there's more pages in here. Also, we have a splice list, because you have some areas where the wires will come together, and then they'll splice all the wires together. And they're maybe even going to completely different ATA chapter items. Wherever you would find the splices at, this is kind of an important thing, because a lot of times your short circuits occur at splices. Because all these wires coming together, there's an insulating jacket on the outside, and then usually a metal shielded jacket on the outside of that. The plastic splits, then you have maybe 5 wires that are short circuiting simultaneously to a metal jacket that goes to ground for noise canceling, and you'll end up with 4 or 5 different warnings on your ICAS system. But it's because you have a short circuit to ground at a splice. So then this tells you what wire bundle you're in. And then this number here for this splice location here. Splice 00047 1040 191 L005. That's station 1040 going lengthwise back down the aircraft. Waterline 194, that's above the cabin 4 line. And it's left, just 5 inches left of the center line of the aircraft, this L05. That's probably near the leading edge of the wing, just above the floor line, about 5 inches off to the center of the aircraft is where that would be located. You guys went to the airlines and you talked to them about the splice list, the wire list, all this other stuff in ATA 91. You'll find the majority of A&P technicians don't even know ATA 91 exists. They've never used it. They've never looked for it. Wiring modifications. Terminal strips. Like I said, that 757, it had 5 separate warning ICAS messages. The mechanics on midnight shift changed 5 different components. One of them was a probe in the inlet of an RB211. We don't have the inlet, but there's a probe there, and they changed this. It's a very simple thing to change. Supervisor ran the engine. Supervisor said, that's good, no warning. Well, I signed it off because my friend was on top of the engine cowl. Supervisor upstairs had the logbook, so I signed that I changed the probe. Plane took off, and the warning message came back again because the fault was on channel A wiring having a short circuit in the terminal block. When we ran the engine the second time, it went to channel B. So the second time when the engine was run, the supervisor ran the engine. We're now going through a completely different set of wiring, and we don't have a fault because there's no short circuit on circuit B. The airplane takes off again on circuit A. The fault came back 2.5 hours into flight. You cannot have that probe. You can't have the anti-icing function in op. So the airplane had to come back again. And when it came back again, they determined by looking at all of the wiring diagrams that we're looking for one terminal block because it was the one thing that was common in all 5 systems. Nobody did any troubleshooting. Nobody bothered to think, why do we have 5 different computers, probes, expensive parts that we're changing at the same time? You don't have 5 different things break at the same time on a Boeing airplane. It doesn't happen. They'd already done the work when I got there on day shift, and so I just I signed the logbook. Everything, the operation had checked okay. Should have questioned it more. I should have said, why did we spend all this time and money changing these components? Why don't we look at the wiring diagrams and find the one common thing in all 5 different circuits in 4 different ATA chapters? ATA 30, there was ATA 22, I think 2 items at ATA 34. But nothing should be relating to each other. Airplane hadn't been hit by lightning. So it's a one common thing, this one terminal block where all these wires came to this one terminal block and the voltage was jumping from one wire to the next. And the messages they were getting in the cockpit were all fake messages. So there's nothing actually wrong with the aircraft. So terminal block, if you had to find the terminal block, now it would say terminal block 0040. Here's a part number. They actually give you the part number, manufacturer part number for the components. You don't have to go look in the IPC. You'll probably never find this in the IPC. And then it tells you where it is. Station 251, waterline 204, and it's right 2 inches right at the center, 204 on the waterline. That means it's fairly high up in the sidewall of the airplane. You'd probably have to get behind a overhead passenger bin. That's probably where that's hiding. 251 inches aft of wherever 0 is, and 0 on 737 is probably out in front of the nose somewhere. So you go 251 inches back from that location, and that's where station 250 is. This terminal block, everything that goes through the terminal block here is all ATA 33. With the airplane I had, the cracked terminal block, it would have had a large number of different items on it besides just ATA 30. So terminal strip list gives you that information. Are there any questions? Hookup list. Hookup list is not a bunch of telephone numbers that you have on Saturday night. Hookup list. This shows you where you have interconnections in the aircraft. Give you some examples. So Delta 0096. It's in the P05 panel. They're not giving a station, water line, butt line, because they just say it's in the P05 panel at location number 10. It's a plug. That plug has got different wire bundles that are associated with it. So through this connector, at terminal number 3, wire bundle 2112, wire number 5544, and it's a 24 gauge wire. It's covered on diagram ATA 36, 2111. So that's a pneumatic system wire. So the hookup list is showing if you have a Cannon plug, every wire that comes off of that Cannon plug now, you can figure out where it goes, what does it do, what is it associated with, what the gauge is, what size wire is it. 24 gauge wires are smaller diameter than 20 gauge. If you had an 8 gauge wires about this thick, that would be in the galley for ovens. The ovens are probably one of the highest power usage components you'll find on the airplane. So the wires for those are 8 gauge wires. Most everything else that you have in the aircraft, the majority of your wires are between 20 gauge and 24 gauge. Usually everything's DC and not very high amperage. You want to try to keep your wiring bundles light. So if they're smaller gauge, the aircraft's lighter, it saves weight, and you use less power. So this one, Delta 00148, is at station 1212, lengthwise station 1212. Water line 284, that's very high up in the aircraft, well above the floor line, and 2 inches left of center. This might be up at the very top of the fuselage, going lengthwise. And it's a plug, and it has 20 gauge wires, ATA 33. Anybody know ATA 33? You should memorize ATA numbers so you'll be ready for projects, exams, interviews. You'll be using these numbers for the rest of your career, so it's good to memorize them. So, if I can't remember 33, but I remember 32. 32 is landing gear, L. 33 is also L. Lights, yes. And then 34, L, M, N, and 34, N, N, navigation. And then 35 is L, M, N, O, oxygen. 36, L, M, N, O, P, P, pneumatics, P, pneumatics. A lot of your ATA items, the numbers, you have an alphabetical list, goes in alphabetical order, and then your numbers are assigned as such. So maybe if you remember 32 is landing gear, then you can remember 33 is lights, 34 is navigation, 35 is oxygen, 36 is pneumatic, 37 is vacuum, which you will not find on Boeing aircraft or Airbus. So when you go to the airline, if you know 37 is vacuum, you'll probably find that the majority of your airline employees didn't know that 37 exists. 38 is W, water and waste. You guys want to be hammers and know all of this stuff so that you'll be too valuable for them to put you on toilets all day. You do not want to be on toilets. When you're new, or if you make your boss unhappy, you make him mad, you'll get stuck with toilets. What respirators are for: wear your white suit, treat it like you're working with COVID, wear a full face respirator, wear a white suit, use 2 pairs of gloves if you're working on the lavatory. Take your white suit, take 1 glove over it, tape it up. The other gloves you can take off and throw away so you can handle your tools, you can handle paperwork, handle a computer, but you always have a barrier to keep yourself protected. If I was working around COVID patients, I would have the white suit with 1 set of gloves to be taped up and another set of gloves as I do different things. those gloves can come off and go into the trash. And also something called Lysol. You can get Lysol. It's a disinfecting spray. It's fantastic. It's better than Dettol. Lysol kills everything. So that's about enough of the wiring diagram. I'm sure you guys are all having the time of your life. Hope you guys all get good jobs. This is an avionics book that I don't seem to have an upload for it for Google Drive, so I'll have to correct that. I thought I had it uploaded, but I can't find the link. But I scanned a book about avionics systems and troubleshooting, and he has really good information on how to use different manuals in this book. And the book's about $85. It's a paperback book. It's not cheap. And he goes in and he explains all kinds of things on how to use different maintenance manuals and how the ATA system goes. So I'll try to get you guys a link for this thing so you can download it because it's very helpful. It's for the avionics side of things, but if you understand your avionics, it helps you as a regular A&P as well. We had an avionics department at Continental, but basically I did all of my own troubleshooting. If I had a significant wiring repair, that required special tools that we didn't have in our tool crib, then I called the avionics department. Usually I never called those guys though because I could do everything myself. So our page blocks, page 01 through 99, description and operation. Then they'll talk about troubleshooting in page block 101 to 199. Maintenance practices, page block 201, 299. Servicing in page block 300 to 399, so almost everything, ATA 12, all of our servicing we've been looking at. The bottom lower page, it will say 300 to 399. If we're going to do bore scope inspection on the engine, 601 through 699, you're going to actually find in the bore scope inspection that 99 pages is not enough on most of the engines. So then you'll have page after 99, then you'll have page alpha 001, alpha 002. If they had to use a Bravo Charlie, they could keep going. So the different page blocks that you're in, that tells you what type of work that it's covering in that there. So if you're trying to figure out how to adjust and test something, but you're busy reading in the troubleshooting section, you're going to have to go back, print up the section or pull up the section that's not in page 601, you need page 501. So that's about your page block topics. This textbook is nice because he actually uses quite a few examples from different pages, and he explains different things like how you can get to know more about your wiring diagrams. So these flag notes he's talking about, these little notes that are here, you then come down and you see what that information is. So this relay right here, it says energize during APU start. Keep in mind that the way that this is drawn, you have your 28 volt DC goes to the circuit breaker. Right here, goes this way to this relay. And you would then go through this part of the relay switch. If the power was applied to the airplane, this relay would close. Wiring diagrams are always drawn with the assumption that power has been removed from the airplane. Because if you're going through these panels with your wiring equipment, you're going through fixing things, changing things, removing things. You're in there with a meter. You do not want to work inside an electrical panel on the 737 if there's power on. There's enough amperage in some of the panels. If you open up the panel on the airplane and you're in working on a relay or trying to take voltage readings, if you short circuit yourself to ground through some of these circuits, there is enough amperage to kill you. Not just burn your tool or shock you, there is enough amperage to just flat out give you a heart attack and you're dead. So you have to remember that when the airplane has power on, power will be supplied and this will close. Then your voltage would then be going through B1 to B2 through this switch. But with power not on the airplane, you would be looking at perhaps you could check the circuit going this way and you would get continuity. So you have to remember that the wiring diagrams are drawn with the assumption that power is not on the airplane at all, because you're following safety protocols and you're doing your troubleshooting with the power off. So when you go to try to understand how the system works in flight, how it should be working when the plane's out flying, you have to sit there and look at this dotted line and realize that yes, those will close when the airplane's actually flying. And when the aircraft takes off, all these circuits, the voltage would be going through this way, through here. And then this would not be closed. You would not have voltage going through from pin A3 to A2 if the airplane's flying. So the flag notes, number 1, number 2, energized during APU start for flag note 1. Flag note 2, it's saying effectivity PA261 to 277. I noticed that the print is different. He's changed this. This is not what Boeing originally had. He's gone and made a change to it because the font is not bold and it's, I think, a different typeface. So he changed the effectivity probably because he borrowed this piece of a document from an airline. So he didn't leave the original effectivity. Also, the effectivity information from this block is missing. It would probably have said something else. This is probably Pan Am Airlines is what he's trying to say. They don't exist anymore, so nobody will really complain too much. July 15th of 1994, Boeing 747-400. I don't think I'd want to use this reference to go work on my 747-400s because there probably has been a change since 1994 to the content of the manual. You want to make sure you use up-to-date manuals. So if anybody wants a copy of this avionics systems and troubleshooting book, I will endeavor to find a link and put it on Facebook so you can find a link. Thomas K. Eisman. We have some other books that you guys have probably used that are very basic. But this particular textbook, when I went through it, it was very advanced in terms of how you do systems and systems troubleshooting. And he covers a lot of different aircraft types. This would be a really good thing to read as you're getting your experience at the real airlines. Something that give you a little bit of extra help in trying to figure out what you're doing. So Boeing 747 P5 panel is on the overhead above pilots. P7 is behind that. P12 is further up. So these are all the P locations. So I've forgotten some of these because I haven't worked. I didn't remember P72. I haven't looked at the 747 and it's been a few years. But very soon I'll be out flying on 747s and I'll have to look at this information and I'll have to memorize it. I'll have to know where the P44 is. The P8, I remember that one. That's pretty easy. But a few of these others like P44, P72, you don't work on them too often, so it doesn't really stick in your mind. You don't remember it as much. It's about time for you guys to think about whether you want to keep going or if you want to call it quits for the day. Mr. Panis, you have lots of questions, I'm sure. Mr. Panis. Yes, no, is anybody awake? Let me see if I can find this troubleshooting book very quickly. Probably get this added so you guys can download this as well. It is 134 megabytes, so you should be able to open it up on your devices at home, be able to save it. It's a very good book. It'll help you a lot if you want to learn about avionics systems and troubleshooting. Add that to our files for the course here for a section. Then you guys can download it from Microsoft Teams. I'm hoping you've already done that before with some of your other teachers. Does anybody have any questions? Comments, concerns? Can everybody say 16,000 bucks? 16,000 bucks. This is why you study. You study so you can make money. Don't go to school to make me happy. Sure shouldn't go to school to make somebody else happy, like your family. They said, oh, you should go to school. Should be something you have a passion for. You want to be an aircraft mechanic. You want to fly on 747s and make. I'd work for free, honestly. This job I'm getting, I'd volunteer. But, they want to give me 16,000 baht every day. I'll take it. But I would do this job for free just for the fun, because I'll get to go places and see things that quite amazing to see. So if you guys don't have any questions, you're free to go. You can wake up, go back to sleep. I am adding the avionics systems and troubleshooting to the files on the class, so you guys can add that to your collection of books at home. So have a good day. Take care. I will see you soon. Next time.
Bye.
Bye.
See you, sir.
Adios,
Goodbye,
amigo.
teacher.
Take care. Wake up, go back to sleep.
Bye, teacher.
Adios.
Take care.